overview of the Gambia, for most of you might not know about the Gambia. It's the smallest country in West Africa, population of 1.9 million according to last census. Census is conducted every 10 years. The last census was 2013. The total land size of the Gambia is 11,000 square kilometers. Many of you might wonder, is this a country? It is a country that is almost surrounded by a neighboring country, Senegal, from both sides, except for the western part, where we have the Atlantic Ocean. The main physical feature of in the Gambia is the River Gambia. River Gambia is a transboundary river basin shared by 4 major countries: Guinea-Bissau, Senegal, Guinea, and the Gambia. The river flows from the Futajalan highlands of the mountainous areas of Guinea, flows through Senegal, and ends in the Gambia, where it empties in the Atlantic Ocean. The main economic activities in the Gambia are agriculture, 30%, tourism, which is about 60%, that is the main source of economy, and we also have export and re-export trade from the port we have seaport that we benefit from as well. The surface water in the Gambia is heavily affected by salinity, especially in areas where population is centered and tourism facilities are located. Based on this, groundwater is the only source of potable water. So as you can see with the current trend of climate change, it will be very important to maximize the usage of this groundwater. We also went further to give groundwater system in the Gambia, which is of 2 main aquifer systems. You have the shallow sand aquifer and the deep sandstone aquifer. Both these aquifers lies across the entire length and breadth of the country. Shallow sand aquifer recharge is mainly by infiltration, where of the DSA, deep sandstone aquifer, is mainly from lateral flow from the neighboring country, Senegal. The water in the deep sandstone aquifer is mainly of very old water of fossil origin that is hardly consumed. According to sources, 80,000 cubic meter of this water is consumable. But however, even with that quantity, it's heavily infected by high TDS content, which make it difficult to consume the water in the event that the shallow sand aquifer is not able to satisfy the country. Based on the problems mentioned above as regards to climate change, the purpose of our study is to look at the impact of climate change on groundwater in the Gambia, particularly on groundwater levels in Brikama. We consider climate variables, rainfall, evaporation, and temperature. We want to look at the variation, the effect of their variation on this shallow aquifer, and as well how it will affect the groundwater levels. We hypothesize that there is a correlation between climate change variables and the groundwater level, which leads to the lowering of groundwater table, especially in the study area, Brikama. Climate change variables, rainfall is positively correlated with groundwater level, as we hypothesize. Climate change variable, temperature also is positively correlated. And climate change variable, evaporation, which is negative correlated, as we hypothesize. The methodology of the study. We first identify and select the study area, which is Brikama, based on the problem as defined above. MLR model, multiple linear regression model, was developed that defined the baseline condition of the study, what data and what else we're going to include in the study. The data for the climate variables were obtained from the Department of Water Resources, which is a secondary data, and the research hypotheses were tested using regression analysis. The groundwater level of the study area were forecasted using a model, ARIMA model, which is used for the factor to portray, as MLR model will derive equations that can be used to predict, but in order to visually portray, we intend to use the ARIMA model. These are the model equations of the two that are used. As you can see, that's for ARIMA model, where Y represents the groundwater level, and you have the beta coefficients and the respondent independent variable. As that of ARIMA model, you have the data in which the time series is applied on. This is the climatic trend of the Gambia. As you can see, as reported by many researchers, the climate change variability impacted on rainfall, temperature, and evaporation patterns. As you can see, the rainfall trend of the Gambia is slightly increasing, even though with high level of variation across the decade. That of temperature is also maintaining an increasing trend, even though with high level of accuracy. As you can see, the highest temperature in the Gambia falls at between 27 and 28. That is the highest temperature in the Gambia, maximum temperature in the Gambia. The lowest temperature in the Gambia doesn't go beyond 19 degrees Celsius. Evaporation pattern, however, many researchers have said that with the increasing temperature pattern and reduced rainfall, evaporation is expected to increase. But however, in our study in the Gambia, in the study area, the evaporation maintains a decreasing trend across the decade. The relationship between climate variables and groundwater level is tested using regression analysis, scatter plot. The groundwater level and rainfall is positively correlated, as you can see from the R-square values, the slope and the probability value, which all indicated the significance of this particular variable to the groundwater level fluctuation. That is the same figure for temperature, which is also positively correlated with groundwater level, as you can see with the R-square and P values constituting the variation which is caused by the climate change. That of evaporation maintains a slightly negative trend. As you can see, evaporation trend in the Gambia is not very high. It affects the groundwater level, but at a very moderate level. The result test of the regression analysis and establishment of model equation, as you can see, as mentioned earlier, regression method will be conducted, and based on the coefficients, the model equation will be formed that can be used to predict the groundwater level, which is seen that from the significance ranking order, all these variables are significant at 5% level and below. We also do standard regression, which only select the most significant variables and leave out the ones that are not significant. Based on these data, 10 observation wells were selected from the study area where Brikama is located. Out of these wells, the observation well in the specific study area, all these climate variables impacted on the groundwater level, but other wells in the same study area were impacted by either rainfall and temperature or rainfall alone, but it's not affected by all these three variables, as you can see, which is also telling you even the wells in the same geographic location has differences. Test of model equation. To test whether our model equation is correct to do the prediction, we do analysis of variance test table, which indicates that all these variables are perfectly well to do the forecasting of this groundwater level. The model statistical summary of the model also indicates the model is a good fit and can be used to do the forecasting of the groundwater level, as indicated by the R-square of 48% of the three variables that are used, and the p-value is also indicating the highest significance ranking order. In order to augment the efforts of MLR in predicting the groundwater level, we also went further to use ARIMA model. As you can see, the time series plot of groundwater level, this is the preliminary assessment of the groundwater level. But based on this plot, you will see the groundwater level in the Gambia is not stationary. It has trends, which need to be detrended in order for ARIMA model to forecast well the groundwater level. We detrended the data by taking the first difference, and as you can see from the plot that is generated, the data appears stationary, that all the trend is being get rid of, and there you can use the data to forecast. But we didn't go ahead and forecast. We need to verify if this is true. The data is actually detrended. We plot what is called autocorrelation test, and based on the autocorrelation, all the lags are within the box. There is no autocorrelation left over, and the results of the residuals also indicates that these are normally distributed and can be used to continue with the forecast. We forecast the groundwater level of the study area for 3 years. As you can see, from 2019 to 2022. Based on the forecast, it is indicated that the groundwater level is increasing. This is increasing in the sense we use positive data. It is not negative data that are used. So increasing trend here indicates a reduction in the groundwater level. Our key findings: statistical analysis of this statistical analysis proved our proposed hypothesis. There is positive correlation as indicated with temperature and rainfall, as well as negative between the evaporation and groundwater level. Strong correlation established between rainfall and groundwater level, which indicate rainfall is the most significant variable as far as climate change variation is concerned to the effect or hard effect on the groundwater level in the Gambia, especially in our study area. 48% of the variation is caused by climate variables based on the R square, and this is sending a signal where lies the 52%, which calls for further research. As you can see, mentioned earlier, we use only 3 variables. In the sense, if you use other variables, this might increase the strength of the R square. The groundwater levels of various wells in the region responded differently to the climate, the effect of climate variation. This also sent a signal for further research. Why wells in the same region will have different responses. That means there are characteristics related to geographically and whatever that needs further research as well. We also expect, based on the ARIMA forecast, that the groundwater level in the study area will continue to decrease. By conclusion, we say climate change variability in the Gambia was revealed through the fluctuation of these variables. However, the influence of climate variables such as solar radiation, wind speed, and direction need to be researched to ensure that this gap left with the variation of these other 3 variables is being filled. This study was the first to employ this statistical model such as MLR and ARIMA model in my country, and perhaps this can be used as a prelude in predicting groundwater level in the Gambia, and also can serve as the starting point for groundwater research in the Gambia. As you can see, groundwater research is not very common in my country. Many studies that are conducted basically focused on population and demand management, but none of them looked at the impact of climate change on actual groundwater level, which is also very important with the current climate change scenario. The analysis of the model results indicated that MLR and ARIMA model developed in the studies are able to predict the groundwater level of the study area. The methodology used in this study shows the feasibility of proper water resources assessment in the Gambia. This can be replicated for similar studies in developing countries where data scarcity was a great challenge to the development of process-based models.